Hello, picking back up with these psychophysical methods. I'll be discussing 5. We finished the ratio scaling, and so I want to move on to method number 2. It is Borg's RPE scale, where RPE, this scale was developed by Gunnar Borg. The PE part, perceived exertion, is the act of detecting and interpreting sensations arising from your body during physical exertions. And then the R part of that is a rating, and so RPE is assigning a rating to your perceived exertion. This scale that I show you on screen is also found on page 120 in your textbook. There are 2 versions. There's a current and an older version. We're going to use the current version, which should be the top left-hand side. If I were to ask you using this scale, pick a number from 6 to 20. So pick one value that best describes your level of exertion right now. And so you're sitting, hopefully you're taking notes, writing some notes, watching this if you're not taking notes. And so physically you're looking at the exertion in your body. So pick a number that best describes your level of exertion. And so mine might be I might say that I think I'm working about at a level of 8. Borg's RPE scale is probably the most common scale in use in physical ergonomics. It's used very commonly. You might have run across it before. It is used in industry, so you might have seen it in your workplace. You might have seen it as you're working out and take exercise classes. Sometimes they'll have this posted on the wall and the instructor will say, I want you at this level, I want you working light, as we warm up, or I want you to be working hard. You should be working at a level of 15. And it's also can be used in rehab, and so you might have seen it in hospitals or rehab facilities. It is pretty commonly used. The values increase linearly with the workload intensity. And the scores of 6 to 20, you might wonder, well, what happened to 1 through 5? Why does it start at 6? The values of 6 to 20 were chosen or were selected because they correlate with heart rate. And so I'm going to have you take a 15-second heart rate. And so if you can find your heart rate, I want you to be counting it whenever I tell you to go. Okay, have you found it? Are you ready? 3, 2, 1, start. Stop. Okay, now that you've got a 15-second heart rate, you know that you multiply it by 4 to get a beats per minute. Okay, so for example, if mine were at my heart rate was at 72 beats per minute. If it were at 72, if I'm saying that the scale was correlated to heart rate, I go back, I picked an 8. And so on this slide, if I multiplied 10 times 8, my heart rate should have been 80. So 10 times 8 is 80. I can see that, okay, it's kind of close. It's kind of close. It's not too bad. But what you're going to find is that this scale, the 6 to 20 scale, works best for cardiovascular or aerobic sorts of activities. One where you're moving quite a bit, you're breathing harder, your heart rate's going faster, beats per minute. And so if you're doing aerobic activity, the correlation is pretty good. Whenever you're sedentary or resting, correlation is not as high, and so I didn't have an 80 beats per minute that would match my 8 rating. Instead, I had somewhat different, and the reason for that is people's resting heart rates are different. Your resting heart rate might be in the 50s or 60s. Some, for example, mine was 72. Other people's resting heart rate is 80 beats per minute, and so they might say that, well, I'm not exerting at all, I'm just sitting here, but still their heart rate might be 80. Okay, so it's really better for aerobic or varied activity. Since it is tied to your heart rate, we know we can set limits on a worker's or on an employee's heart rate, that they shouldn't be exerting more than 220 miles their age at the highest, Well, we can also set limits on a daily basis so they don't become overly fatigued. And so for our RPE, we're going to set limits for an 8-hour workday, and those limits will be based on a daily average. We just took one RPE reading, but really to use this, you would need to take a random sample throughout the day, maybe one in the first hour of work, one in the second hour, one in the fourth hour. You would take it at random times throughout the day and then average those. So you get a daily average. The daily average RPE must be there's two possibilities. If a person is doing full body and or leg work, the average RPE for a day needs to be less than or equal to 11. If they're doing upper extremity work, they're only doing arm work, then arm work is more stressful on your heart, and so it has a lower limit. The average RPE should be less than or equal to 10 in that case. Okay, so this is a daily average for an 8-hour workday. An example of using the RPE scale is I have four workers that are shoveling raw materials, and I've asked them to give me an RPE value several times throughout the day. I took an average so that subject 1 or worker number 1 gave me a value of 7, or his RPE average was 7. For worker 2 it was 10. Workers 3 and 4, they each gave me 9. And so my first question is, as a group, are they working too hard or are they working within acceptable levels? And really I'm looking at, okay, they're shoveling today. Is it at a level that's acceptable that they can come in tomorrow without being too fatigued, that their body has time to recover? Tomorrow, the next day, next week, next month, and so on. We want them to average low enough that they don't come to work feeling overly or too fatigued. To answer question 1 as a group, so we're looking at a group average. For this one, I would just simply average the 7 plus 10 plus 9 plus 9, divide by 4, and come up with a group average of 8.75. 8.75 is the group average RPE. I want to compare that to my limit, and so the question is shoveling raw materials, is that whole body work or is that upper extremity work? And you're going to say, well, shoveling I use my arms for, and it's like, yes, but you also use your back, you also use your legs, and so you are using your whole body. Since it's a whole body work, so full body, whole body, my RPE average needs to be less than or equal to 11. We see that 8.75 is indeed less than or equal to 11, and so therefore this is an acceptable task. They are not working too hard on this task. Second question is each individual working within his or her own acceptable level, and you're going to find that people's fitness varies, and so they're going to have different scores because the same task is going to feel different to different people. Some are more fit, some are less fit, and so individually you're comparing, are all less than or equal to 11, and you're going to say that yes, they are. And so again, the task is acceptable to each of these workers that I have on the task. So task acceptable to all workers. You're going to say that shoveling is difficult work. It's hard manual labor. Why are my scores so low? And I would just reference, as you're driving down the road, you see workers, typically men, they're digging for some utility company. What do you see? You see one person shoveling and then 2 or 3 resting, talking, chit-chatting. One person shoveling, 2 or 3 resting. And so they're rotating the task around to the different workers, meaning that they work hard for a bit and then they rest. They have a rest break. They work hard for a bit and then they have a rest break. And so those times that you think they're just talking and chit-chatting and wasting time and getting paid to do nothing, they're actually recuperating. Down, and so our job has been set up, the pacing has been set up that they do have periods of work, but they also have rest breaks, and the breaks that we've given them are sufficient that they feel like they can handle the job and come back the next day not feeling too fatigued. Okay, so that takes care of RPE. My third method is the CR10 scale, the category ratio 10 scale. This relates to Stevens' law. Borg received the criticism that well, the 6 to 20 RPE scale is linear. It is not a power function, and so he came back and, okay, I'll give you one that's a power function. And so the CR10 scale, notice that the values, there's decimal points on the lower end. The scaling is tighter down at the bottom. It's larger at the top end of the scale. There's several numbers, several values between the descriptions here. Okay, so that is designed to meet the Stevens power function law. Anchors on this and anchors on the other scales. I also just wanted to mention they give everyone, no matter the fitness of the body, the musculature you have, it gives everybody, if they pick off the score of 2, it's interpreting it is 2 for your own body capabilities. This particular scale is not correlated with heart rate. It's not this physical activity that's stressing your heart and lungs. Instead, it's best for subjective aches and pains. And so it's really good for localized muscle use, such as your MSD types of activities. I wanted to mention it's also copied on page 120, and where you're using the more current version of this. Okay. This one, I could ask you, how would you rate the work performed by your hands as you're watching this lecture, as you're taking notes? How would you rate the work performed by your hands? So pick off a value. And I would guess that some of you are at maybe a 0.5, a 1, 1.52. Okay, so you're evaluating, you're taking notes, you're writing or solving problems, probably on the lower end of the scale as you're writing naturally. For this scale, there are no set recommended limits on it. Instead, it's as you're doing activities with your hands or using the localized muscles, the smaller the better. So the smaller numbers are better. So no limit on it. The fourth method is the visual analog scale or VAS abbreviation. In this, we present a 10 centimeter line, and so obviously the line is a different length on screen, but we present a 10 centimeter line. It has verbal descriptors on it. This line runs from easiest imaginable work to hardest imaginable work. You're going to ask the employee to mark his response of what he thinks his job is on this scale. He's going to just identify a value. And in the score, how you score this, rather than picking or identifying a number, your score will be the distance from the left-hand side in centimeters. And so obviously you would need a ruler, a tape measure, some sort of measurement system to identify the size of this. So how many centimeters out of a potential 10 centimeters? And you can see that this is basically a percentage. Variations on this is that you can change the length. Psychologists have tested different lengths. They found that 10 centimeters and 15 centimeters had the best consistency, the best reproducibility, and so try to stick with 10 and 15 centimeters. The endpoint descriptors, you can vary those. Right here you've got easiest imaginable to hardest imaginable work, but you can really vary that on almost anything that you're interested in. You could change, instead of easiest imaginable, you can change this to comfort. This is very, very comfortable to very uncomfortable. You could change it to size and do too small to large. Oops. Too heavy to light. If you looked at quality, you could go from very poor to very good. And so you can use this sort of scale to evaluate a whole variety of things. You might have run across discomfort analyses, so your discomfort surveys, which is essentially a body diagram, and you might have seen it with a Likert scale of identify 0 to 5 or 0 to 7 or 0 to 10. You can also, with this body diagram, use a visual analog scale. It can be used to assess overall body discomfort, or as this example shows you, this individual body part discomfort. You can use a VAS to look at frequency or severity. This scale that is shown has no discomfort at all to worst imaginable discomfort, and you can see that that is actually severity. So what level of discomfort is it? How severe is it? You could also change it to frequency to have from how frequently to experience discomfort in your hands or in your head neck area. Frequency can be from never up to all the time. And this is a subjective, again, psychophysics is subjective. And again, some people are hesitant to trust it, but we use psychophysics a lot in the MSD arena because, well, oftentimes early development of MSDs, we cannot measure it in any way. We rely on what a person's feeling. They have to tell us. And so we rely on psychophysics to catch this early discomfort, early MSD. Okay, with that, I would like to pause before I pick up the examples on the fifth method.